And it looks like we are going. Can you see me? I am on the camera. It looks like we have no dropped frames. Yes, I think everything might be working as it once was long ago. You remember when the webcam used to work? Hello, SKM. And we also had, we could have that and the triple broadcast at the same time on YouTube, Odyssey, and Rumble. Hello, Checkmate. Yeah, I think we're finally back at that point. Been a while since I've been on the cam, and the lights are kind of hot, but the AC should be working. I got it a bit lower for now, but hello everyone. Welcome to the live stream for June. It's not quite last minute, but I mostly scheduled it at this time for Fourth Root, who has some things he wants to talk about. You might have seen some of his requests on the Discord for a thing he's doing. I'm going to let him talk about that when he comes in. He just texted and said he should be in a minute. Political Checkmate says, I am going to college soon. Any advice? Just try not to let it interrupt your education. That's the best advice about that. I think it all depends mostly on, are you going to a state-supported college or a private college? Because private colleges are more expensive, but there's a lot less of the indoctrination that you get out of those. I don't know if you want to keep your anonymity or if you want to let us know which college it is, at least. That's it's a state college, yeah. Yeah, you're going to learn how to parrot the professor is what you're going to learn. I mean, you can learn some other stuff too, but that's kind of optional. It depends on. I mean, a lot of times it can be an opportunity because colleges have a lot of resources that, you might not be able to get anywhere else. And if you can take advantage of those resources, then why are so many colleges left leaning? That's something that's been kind of building up for a long time. It's been kind of a gradual takeover of academia. If you go look at 100 years ago what the Socialist Party was talking about, they were talking about basically, well, we know we have a two-party system and it's hard to get a third party going. So their idea was to take over the Democratic Party, which, let's face it, they pretty much did. And they were also going to take over other institutions such as academia. And it looks like as far as the state-run colleges were support that are concerned, they're largely successful at that. I'm sure there are exceptions, and I'm sure there are private colleges that are going to indoctrinate you, but it's probably less of a chance that you'll find any kind of indoctrination. Do I have some? I have some noise going on in the background. Hang on, I think my mic settings are off. Check, check. Does that sound any better? That might sound better. Hello, Fourth Root. How you doing?
Hey, how are you doing? Can you hear me all right?
You're kind of faint, but other than that, I can hear you. Faint is in you're far away from the mic. I think the levels might be okay. You just need to get a little closer to it.
Yeah, just give me a second.
Advice on doing calculus. I don't know. Calculus always came kind of natural to me. So I think that's it. Just kind of see how much of it you can intuit. I think people get bogged down in the details of what the symbology means. But it's really, the symbology is just a way of communicating concepts, and it's the concepts that are important. And if you have an intuition about it, you're going to rely a lot less on your memory. Yeah, no problem. And sadly, that's what a lot of learning is these days. They just want you to memorize things and regurgitate them and be a nice little trained monkey. But SKM, there's a theory that the reasons many Democrats turned their states into sanctuary states is because the last census really spooked them. You think the census needs to be changed? There was always that problem with the census. Oh, that's no problem, Chris. We got Alex here as soon as he sorts out his mic issues. Now, am I sounding fine? Is my mic too hot? I'm right in the yellow on the VU meter, so it seems like it should be fine. Yep, I was spending most of the day re-encoding the podcast archive, which is supposed to be something I just do quickly and put up and don't have to worry about it. But the other Odyssey and Rumble were fine, but YouTube kept choking on it for some reason. I had to like crunch it way down to where a 2 gigabyte hour and 20-minute video was down at like 200 megabytes.
How's that? Is this better?
You're still very distant. Make sure you have the right microphone selected and we're not hearing you from a webcam or something.
Did the sound change at all?
No, you're still very distant.
How about now?
You're still kind of faint. I can probably turn you up a bit here, but I think it's going to be that distant sound. I bumped you up a bit, so try it again.
How about this? Is that better?
I think I put you up into the red there. I need to bump that back down a bit. Say something.
Let's see. Input
Yeah,
sensitivity.
I got your levels fine now. But I also, yeah, it just sounds like you're further away from the mic. I mean, we can understand you if we just want to keep going with that. But yeah, sorry about that, everyone. I normally try to sort that out before we actually start broadcasting, but that's just the way things are going today. So is fourth we're going to talk for hours and hours and hours about nuclear science? If we're lucky, we can only hope. Yeah, let's not spend hours and hours trying to get the mic levels working. It's not just his fault. I was kind of last minute coming in here too. So I'm still kind of setting up mine. Yeah, a lot of this just has to do with how crazy our immigration system has gotten. Because back when all this was set up and they first came up with the census and everything, there wasn't really any distinction in the census between you're an immigrant or not. Because remember, they weren't restricting immigration, only naturalization. It was like more than 100 years before they started going against just immigration. And now there's this crazy bureaucracy when it comes to immigration, and they wonder why people are coming here illegally. No one ever learns. Yeah, as far as political clubs, it just all depends. You might think a libertarian club, but some of them are kind of useless and some of them are just. Didn't Clinton and Obama deport and turn away more immigrants than Trump? Yeah, pretty much. Trump's just more vocal about it. Because now all of a sudden people are like, well, what about due process? Well, that is the due process. You're taken before the immigration court and you get to say, hey, no, I'm here legally or whatever. And if you lose that, you get to appeal. And if you lose that, you get to appeal to a circuit court. But they just hope you'll listen to the soundbite and believe it instead of actually thinking for yourself. Oh, the Iran situation. That's been a problem for a long time. That's not anything. Policy of treating ex-convicts like second-class citizens. Yeah, I think that if you've served your time and you're past your sentencing, you've served out your sentence and everything, you should have all rights, privileges, and immunities of citizenship restored to you. What's the real difference between Austrian and Chicago School of Economics? Chicago School is based on monetarism, and the Austrian school kind of went its own way on the boom bust cycle. Okay, you back?
Yeah, I switched over to my phone instead of my laptop, and hopefully that solves most of the problems.
Okay, yeah, we're gonna go with it.
Okay, good. Let's just dive right into this survey that I was conducting. Wanted to
Tell us
identify.
about it.
Yeah, I just wanted to identify, maybe some areas that people don't understand that much about nuclear physics and or various things. See if there's any correlations with policy. I don't think I collected enough data from different demographics well enough so that we could draw any conclusions about correlation with opinion. But I got about 20 responses, and that can show some clear trends in terms of common misconceptions.
Yeah, mine's one of those, and it's one of those situations where I saw it early in the morning before the pain medicine had kicked in, and I'm like, I really should wait until my brain is better off because, first of all, when you just get up, and second of all, when you're in pain, things don't work as well. But my brain doesn't work that way. I had to go ahead and take it, so I probably didn't do 100% what I should have. My first question is, you called it public understanding of nuclear science. Did you mean for that to spell out puns?
No, but that's a clever observation there.
First thing I noticed. That's also how my brain works.
So I've got the response here. We got 20 responses. 55% had 4 to 6 years of college. 25% with 6+ years of college. We got 1 doctorate, it looks like. And then a high school graduate and 0 to 2 years of college. So we actually had a pretty educated sample size there for whatever reason.
How does it
Let's
go,
see.
like, across the political spectrum? Right, left, libertarian, otherwise.
Well, there seems to be somewhat of a bell curve with an overlap of excess far right accounts here. So we got 6 centrists, 6 far right, 3 leans right, 3 leans left, and 2 far left. So yeah,
Did you
somewhat
post it to
of a mixed
Bluesky? That
bag.
might have gotten you some more leftists.
I don't have any followers on there, and I posted it to some liberal friends, and I asked them to spread it around. So I did get a couple of responses that way. If I had just stuck to X, I think they all would have been leans left or to the right of that. So one thing was I asked generally, what is your opinion of nuclear energy? And I got 95% positivity,
Good to
including,
hear.
and only 1 neutral. And that was from a far left individual. I'm pretty sure I know who that individual was. And yeah, it might just be that, I'm only getting sample sizes from friends of mine, but I was surprised that I got 95% agreement that it's a positive thing. So that was interesting.
Yeah, I mean, if you
What is
have
your
the
opinion?
money, you can always hire pollsters to do that, and they can try to get you bigger numbers and get you better cross section of things.
Yeah, I'm cheap though. So
I know
um,
the feeling. Look at this
yeah.
live
So what
stream.
is
You can
your
tell I'm cheap.
yeah? So the next question was, what is your opinion of Trump's recent actions of bombing the Iran nuclear facilities? We got 50% said should not have been done, 30% said neutral, and 20% said had to be done. Naturally, none of the leftist accounts said anything other than should not have been done. So there was only a few conservatives who, 4 conservatives total, who said it had to be done.
Yeah, I mean that's
Um,
still considering that most of the conservatives would have said either they weren't sure or whatever it was, or that it shouldn't have been done. That says something.
yeah. Well, there
And
was a
even just
mixed
from what
bag.
I'm seeing, like on X and everywhere else, the conservative commentators and everything, they're at the very least split on it. Probably weighted towards, yeah, you shouldn't have done that.
Yeah, there's been some pretty significant lessons over the last 20 years or 25 years that about
To say the least.
foreign intervention. So, yeah. Um, Next question: how prepared do you feel you are for a nuclear war? Not prepared at all. I have some supplies, but nothing out of the ordinary. I have a decent amount of supplies, and then fully prepared. Nobody has considered themselves fully prepared. About 15% said they had a decent amount of supplies. 45% had just normal disaster supplies. Nothing's too particular. I myself would have fallen more in that decent amount of supplies. I have a Geiger counter. I have stocks of food, and um, I have some plans on what to do in that event. How
Yeah,
about
I'd be
yourself?
done for.
Okay. Well, next question was which particle is least massive? This was just a simple, science trivia kind of thing. And 90% of the population got it correct with the electron. What charge does a neutron have? 75% got that correct. How much more energy does a nuclear weapon pack pound for pound compared to conventional explosives? Now, admittedly, this wasn't the most objective question that I put out there. I was kind of being a bit vague, but I wanted to
Yeah,
gauge
and
about
there's quite a
how.
range in there with both
Yeah.
of them, you know.
Yeah. Now, Fat Man and Little Boy were kind of anomalies in that they did not try to optimize the power of these weapons, whereas modern warheads they are more efficient. So,
Well, and on the other end,
what I can.
Zarbama is also an outlier.
No, actually, Zarbama pretty much it was a very massive device, and it pretty much fits into the 1 million X category. Now, fission bombs, um, like Fat Man, Little Boy, or even the best fission bombs are substantially less powerful pound for pound, and so that those might actually count more to the 10,000x. But I was going for about 1 million, and that was the plurality opinion. About 35% overestimated the power of nuclear bombs. And like one person thought it was like 10 billion to one. So, but yeah, it's general rule of thumb would be it's about 1 million x because 1 megaton nuclear warhead weighs about a ton. So anyway,
Yeah, and
next question.
they
What?
found out. I think this was shortly after Zarbama, but I mean, both the U.S. and Russia found out that if you get up and up and up in megatons, a lot of what that extra megatonnage is doing is destroying more the things that the lower tonnage would have destroyed anyway. So a lot of that was just a waste as opposed to, making smaller, megaton bombs or less and just dropping more of them, scattered around.
Yeah, exactly. There's, you know, although you pretty much arbitrarily scale up the power, but that relates to a later question, so we'll get to. The next question was, what is an isotope? Um, this one, 52.4% got the correct answer, although I will say that D would have also been close enough. I mean, if you're skimming the questions, you might not have understood the difference between D and E. Uh, so for about 3/4 of the
Now, what was
respondents
D and
got the
E?
correct one. So D was an atomic nucleus with a specified number of neutrons, and E was an atomic nucleus with a specified element and a specified atomic mass.
Yeah, I kind of remember that one thinking there was probably more than one valid answer.
Um, well, there really is only one valid answer technically. It is E. Um, if you're specifying an isotope, you're saying which element it is, which is akin to saying how many protons it has, and you're saying what its atomic mass is, which is akin to saying uh, uh, how many neutrons it has. But technically, you could say a nucleus with an atomic mass of this, and you wouldn't necessarily specify how many protons it has because you're not naming the element. But
Oh, I
anyways,
see.
looks like the trend that we're seeing with these is about 3/4 of the respondents understood what they were talking about. So here's the first question that a lot of people got wrong, um, and that is which element has the lowest energy potential? And I gave the options of hydrogen, helium, carbon, iron, lead, and uranium. And the correct answer is iron. So the uh, plurality of people got this one right. But yeah, every answer was represented. People really didn't get it all that often. This is an interesting question because if you understand mass energy equivalence and you look at the mass per nucleon curve, which we might be able to pull up here, mass per nucleon curve. Um, yeah, if you just Google it, you get search mass per nucleon curve, and you can see a curve of all of these elements, and iron is right there at the bottom of it. And this explains how you get energy out of fissioning uranium to make smaller isotopes, and it also explains how you get lots of energy out of fusion. Anyway,
But also why you can't really get
we,
energy out of fusing iron, which is
right,
why stars stop at
and
that
that's
point.
why. Right, they stop at that point because that's an endothermic reaction, and when stars undergo supernova explosions, then it actually does fuse iron nuclei together endothermically and produces lots of heavy elements. But yeah, generally speaking, everything is going to become iron eventually in the future because it is the lowest energy state. What is the heaviest element found in nature? Most people got this one correct. 80% said uranium. Um, Two people said guessed plutonium, and there could be a caveat in that, in extremely rare situations where you have uranium ore, you can get weird nuclear reactions that produce extremely trace amounts of plutonium. But it's not enough to harvest. It's not economical to extract the plutonium from natural sources. And you're talking about producing, you know, vanishingly small amounts, like a few atoms in moles of this stuff. So um,
Well, and also if you're
anyway,
talking about like supernova explosions, there's probably a lot of heavier ones they think there
oh
might be,
yes,
but they would only exist for like a few seconds or minutes or whatever. They wouldn't stick around that long.
right. Yeah, so there are some, in like the clouds around supernova. I believe this most stable transuranic isotope is an isotope of plutonium with a half-life of about 20 million years. So we might be able to
Wow.
actually detect it in space in clouds, but yeah, it would. It's not going to be very common. Um, what is the heaviest stable element? Again, 3/4 of the population got this correct. It is lead. Um, yeah. Um, an interesting little piece of trivia is that bismuth is effectively stable. It has a half-life of about 10 to the power of 22 years, which means if you have a chunk of bismuth, you have to wait months for even a single atom of that thing to decay. So it is effectively completely, it is effectively stable, but though it's technically radioactive, and it's
What
actually
is that?
an
10 to the
ingredient
21.
in
Is that a quintillion?
um, that would be a sextillion.
Yeah, so I mean
So
we're
10
talking about
sextillion years.
long,
Yeah.
long, long after, where the age of the universe, not only so far, but how long they think the universe, might live before heat death, before, you have half of it remaining.
Right. Yeah. It's um, for all intents and purposes, it is totally stable. And in fact, it's so, you know, it's an ingredient in Pepto Bismol. Bismuth subsalicylate is the active ingredient there because bismuth not only is, effectively inert radiologically, but also chemically, it's a very biocompatible, which is unusual for a heavy metal. Okay,
Yep.
so let's see. Heaviest stable element. Which form of radiation penetrates matter the deepest? People guessed alpha or gamma. The correct answer is gamma. Gamma radiation can penetrate through, several feet of dense material like concrete or lead or water. Um, Whereas alpha radiation is actually the exact opposite. alpha radiation can be blocked by a single layer of aluminum foil or even plastic. It'll travel about 4 or 5 inches through air. So whatever a thousandth so I guess that would be like a tenth of a millimeter through most solid or liquid matter is usually sufficient to block it. So 85% got that one correct. Then which form of radiation carries the least energy? This was split 30, 30, 40. So nobody, I think it was anybody's guess. The correct
Yeah.
answer is beta. Beta radiation is an emitted electron, whereas alpha radiation is an emitted helium nucleus. So when alpha radiation is emitted, what you have is a positively charged nucleon being generated right next to another positively charged nucleus, and so it repels and gets pushed off at relativistic speeds. So it actually is a very efficient form of, almost all the energy released during an alpha emission goes into kinetic energy of that helium nucleus. And that is why it actually carries a significant amount of energy comparable to the almost as much energy as gamma radiation. This goes on to our next um, so gamma and alpha radiation carry multiple mega electron volts worth of energy, whereas beta radiation just kind of balances the nucleus out, and it emits an electron, and so not a lot of energy is carried away with that electron, less than a mega electron volt typically, and usually this means that radionuclides that emit beta particles typically also are gamma emitters, because what it does is it forms an unstable energy state in the nucleus when it decays, and that manifests in the form of a gamma emission alongside the beta. Anyway, we can move on. Which form of radiation is photonic? Photonic meaning a form of electromagnetic radiation as opposed to matter. So beta radiation is electrons, alpha radiation is helium nuclei, gamma radiation is photonic. Which of the following forms of radiation is ionizing? Most people got this correct, 85%. X-rays. A couple people said microwaves, and one person said infrared. So I'm guessing they were just totally guessing and had no idea.
Yeah, that's totally the wrong end of the spectrum. You've got all the
Right,
visible
exactly.
light in between those.
Right. Which of the following elements is naturally occurring? 95%. I was actually kind of surprised that 95% of people got this correct, because I put up 5 elements that I think most people haven't even heard of: americium, plutonium, promethium, radium, and technetium. But I mean, I expected people had heard of radium, but they might assume that it was synthetic, like plutonium or something. But nope, 95% of people got that correct. Radium is the natural isotope.
Yeah, I mean, I think if you know radium, you probably know about Marie Curie and her discovery, and of course what it ultimately did to her. But that's kind of what lets people know. Okay, that's the one that people found, as opposed to having to create in a lab.
Yeah. Yeah, but it's interesting because so far it's correct answers have hovered around 75%, and for some reason that's some trivia that just about everyone knows. Okay, which of the following materials are necessary to produce a nuclear bomb? Almost everyone got this correct. Either plutonium or highly enriched uranium. Either one will do. Those are both considered fissile, so they work. What does it mean for uranium to be enriched? most people understood that it involved elevating the concentration of one isotope over the other. 60% of respondents correctly identified that as U-235. 35% of respondents incorrectly identified it as U-238. And then there was one person who was totally off, thought it meant that it has been isolated to its elemental form. Anyway, which ratio is closest to the natural ratio of U-235 to U-238? Got 55% of people got the correct answer. It's about 100 to 1. So U-235 makes up about 0.7% of natural uranium, and over 99% of the rest is U-238. So yeah, the rest of the people appeared to have just guessed totally randomly. In what way are plutonium nuclear weapons easier to produce? This one, I think, was one of the more challenging questions. I think this is one of the few questions that the majority of people got wrong. The majority of people said all of the above. I always kind of figure, there's usually a strong tendency for questions that give you the option all of the above, that all of the above is the correct answer. So,
especially if it's
yeah,
not in any of the other questions.
Yeah, I deliberately kind of deceive people here in that I included an all of the above answer, but the correct answer is that it is easier to separate plutonium from uranium than U-235 from U-238. So, U-235 has the exact same chemical properties as U-238, so you can't crystallize it and get a higher concentration. The only way that you can do it is taking advantage of the slightly different, gaseous diffusion contents or constants, or the kinetic energy of it in its gas form, basically, and that's how they do it with centrifuges. And you only get a tiny fraction increase in concentration with each stage of doing this, and it takes a lot of energy. So it takes quite a lot of energy and effort to separate U-235 from U-238. But the advantage is if you actually do that, making a nuclear bomb is a lot easier because you can make what's called a gun-type nuclear bomb, where you use high explosives to propel two hemispheres of this stuff into each other, and when they collide, they will explode, and you get a successful nuclear detonation. However, with plutonium, for whatever reason, that method of driving those hemispheres together is impractical, and I think that has to do with the plutonium's half-life being so much shorter, that it undergoes spontaneous fission, and the reaction kicks off much earlier in this process, and so you would get a very small nuclear explosion, as basically these hemispheres would heat up and bounce off of each other before they fully came together. So it would actually be better. That's why plutonium-based nuclear weapons are implosion devices, which means that you have to surround the core, this sphere of plutonium that's just shy of the critical mass point. You explode all of these simultaneously. Explode all of these detonators around a shell that has this complicated geometry of two explosive mediums. So it creates a shock wave that gets shaped spherically and is imploding inwards, and you have to have microsecond, if not microsecond precision on getting all of these detonators to explode at the same time, which was a major challenge in the Manhattan Project. It was incredibly difficult to make a nuclear bomb out of plutonium, it turns out, but very, very easy to make it out of U-235, except for it's a lot harder to separate U-235 from U-238. Anyways, I think I rambled enough about that. What is generally considered to be a lethal dose of radiation? Most people got this correct, 65%, 5 sieverts. I wouldn't really blame anybody for not getting this one correct, because there are like 4 different metrics for radiation exposure. There's rads, there's grays, there's rems, and there's sieverts. But sieverts is the SI unit that factors in the difference in. It's not just the energy absorbed per kilogram of biomass. There's also a factor in there that alpha radiation, for example, is much more harmful than gamma radiation. When the exposure is internal. But anyway, let's see. What is generally considered to be a normal annual dose of radiation from natural sources? This is why I included both of these questions, because I wanted to gauge how much, how many years worth of background radiation is equivalent to 1 lethal dose. So we could actually dive into this further and see how many people. Well, I guess I would have to look up all of the individual answers to this, but we could see how many people correctly got the right proportion. Because only, let's see, 50% got the millisieverts right, 65% got the lethal dose right. So less than half of the population understands that it takes about 1,000 years of normal background radiation exposure to deliver what would be a lethal dose. Anyways, that was the point that I wanted to make there, or rather test people on. What is the approximate yield of a typical fission bomb? Again, this is a little subjective because there is somewhat of a range here. There are actually fission weapons that are extremely low in their yield. But by the way, since I've been talking exclusively here for a while, am I still coming through?
Oh yeah, we hear you.
Okay. I just want to make sure the connection didn't drop, and I've just been talking to myself. Anyway, but yeah, it's 5 to 50 kilotons is a typical fission weapon. That's what people could make easily. And then approximate yield of a typical fusion bomb. This one people were less familiar with, it looks like, because a lot of people said greater than 5,000 kilotons or 5 megatons. The correct answer is actually 500 to 5,000 kilotons. That's what proves effective tactically. As you mentioned, you could make a really big, like Tsar Bomba, but it's not going to kill that many more people than the 5 megaton standard nuclear warhead, or that'll destroy the whole city. Because you're just destroying everything else more. But anyway, 500 kilotons to 5,000 kilotons is the correct answer. Enrichment typical for use in a nuclear power plants falls within which of the following levels of enrichment? The correct answer is 1 to 20%. It's actually typically around 3 to 4% in the rods that they use. But 20 to 80% becomes relevant because under the right circumstances, that could be made to be weaponized. Although there are some niche research applications where you might want enrichment between 20 and 80%. 80% was approximately the enrichment of Little Boy. And then greater than 80% is typically what would be considered weapons grade. And there's really no point in enriching it, beyond 99%. So
And just to give
anyway,
people a little more
uh,
information, we've been talking about some of the new fast reactors they're making. Those are enriched to just below 20%. It's called HALEU, high assay low enrichment uranium, and that's also what medical reactors use. So it
are
seems
you
like
talking
the
about
civilian
some of
uses of it,
the
the peacetime, the peaceful solutions of it, I don't really know of any other than, like you said, some experimental stuff. Of any
are
reason
you
why
talking
you'd want
about
to go
like
over
the
20%.
are you talking about like the small modular reactors?
Yeah,
Because
yeah,
the fast
like
breeder
natrium.
reactors. Oh, okay. Yeah, because fast breeder reactors are an interesting beast because once you get them going, then when you do replace rods, you can replace those rods with natural or even depleted uranium, and they generate enough plutonium that they can sustain their fuel cycle that way, which is interesting. Um,
Yeah, but
okay,
natrium's nice
enrichment.
because with breeders you have some escalation concerns. Natrium's not a breeder; it just burns it all, and you're just left with the lower
Mhm.
level wastes when you're done.
Yeah, that's good. Um, okay, enrichment typical for use in nuclear weapons falls within which of the following levels of enrichment? And that was 80%. Okay, so we just talked about that. Then I got to a whole bunch of these true-false questions. Um, First question, nuclear bombs can be used to generate EMPs that can disable electronics and power across a wide area. 80% of people said that that was true, and they are correct. It can be detonated, yeah, high, like basically in outer space. And, if you get a large enough weapon detonated, a couple thousand miles above Kansas, it could, in theory, knock out power for the entire U.S., which in itself, depending on how devastating that is to our supply chains, it's hard to say how people would respond to something like that. But it could have massive food disruption, and could kill more people than blowing up a single city. You might have mass starvation in the tens of millions. But that is more questionable because it's hard to imagine how the world would respond and how the economy would respond, uh, and help from outside would affect that. Anyway, uh, nuclear question two: nuclear fallout is dangerous for thousands of years. I specifically put dangerous in there because obviously nuclear fallout will exist nigh indefinitely. It's got half-lives, and some of these elements have half-lives in the hundreds of thousands of years. But there are uh, strontium-90 and cesium-137 are two isotopes in particular where there is a big gap between them and the next longest lived isotope, which is like 200,000 years. So the isotopes that live in the hundreds of thousands of years or millions of years, those emit so low of radiation that I would not consider them dangerous unless you somehow gathered them up and concentrated them. Um,
Yeah, that's actually
but,
what the long
and
half life means. A lot of people seem to think that longer half life means it puts out more radiation. It actually means it puts out less because it takes longer for it to get rid of half of itself.
exactly. So there's this big gap. And if you assume that you just go long enough for anything with a half-life shorter than cesium-137 or strontium-90, which both have half-lives of about 30 years, then you could say that it's not dangerous. So it turns out new radiation, the nuclear fallout, um, is not going to be dangerous more than about 400 years, no matter how contaminated your soil is going to get. Um, and typically, if you're dealing with the nuclear fallout in a local area for from the result of one nuclear bomb, and not like specifically at ground zero where concentrations are higher, but typically the recommendation is to stay inside for a matter of weeks, stay in a fallout shelter. After a matter of weeks, all of the really short-lived stuff is decayed away, but there might be some hot pockets in there. But anyways, the point is, thousands of years, definitely not. And most people understood that, although 25% still got that wrong. Number 3 of the true false, bombing a uranium enrichment facility is likely to produce dangerous fallout. This was almost split. 40% said that that was true, and the correct answer is that that is false. That even uranium-235 has a half-life of like 200 million years. So if you disperse all of that material, and they only have like a few hundred kilograms of material on the site at the most. So if you disperse all of that material, it's really not going to cause a problem unless you're like pretty much at the plant and get exposed to it, inhale it basically. It's really not going to be a problem. Bombing a heavy water facility is likely to produce dangerous fallout. Most people got that one correct. They understand that heavy water is not radioactive at all. It just has a higher proportion of deuterium to the normal isotope of hydrogen 1, or protium. But the reason why heavy water is used in the nuclear industry is because it serves as a moderator. And if you can produce lots of heavy water, then you can design a nuclear reactor that operates off of natural uranium, and you don't even need to enrich uranium, and you might even be able to breed plutonium that way. Next question. Bombing a nuclear power plant is likely to produce dangerous fallout. 3/4 of people got this one correct. It is true. And with the caveat that you need a special kind of bomb, like a bunker buster bomb that can penetrate the containment facility, which is a very big, thick, rigid structure that, unless you have bunker buster bombs, it's not, there's no way like a terrorist with a bundle of dynamite could cause a problem. But
yeah, they did experiments on them. You can see the videos online where, they just build a section of the wall, and then they throw a missile at it, or throw an airplane fuselage at it, loaded with fuel.
Yeah.
And it just blows up, big fireball, and it's not even cracked.
Right. Yeah. It's like 2 meters of reinforced concrete. It's not going. Nothing's going to go through that unless it's designed to penetrate concrete. So, the next question: all nuclear bombs produce fallout. This was interesting. 35% of respondents said that was true. And they're right. All nuclear bombs do produce fallout. I'm surprised that that seems to be one of the biggest common misconceptions here. You can't have a nuclear explosion without producing fission products. Even fusion bombs depend on fission triggers to function, so they produce fission products and produce fallout. Now, if the bomb is detonated high up in the atmosphere or even in outer space, then it's unlikely to produce any localized concentrations of fallout sufficiently dangerous to be of concern for acute radiation poisoning, but they all do produce fallout. The next one: the world has come close to full-scale nuclear war on multiple occasions. 85% understood this to be true correctly. There's been things like, do you ever celebrate Petrov Day?
No, but I've heard of it. I knew who Petrov was.
Yeah, yeah. Petrov was a was he an officer, or he was
I don't
involved in the
remember
chain of
exactly, but I
command?
remember he was the guy who he was one of the designers of the facility and he wrote the software and he understood the system better than anyone. And so he was
Hmm.
probably the best one to be skeptical about, like, oh, there's this blip. That means they've launched nukes. That means we should launch them back.
Hmm. Yeah. So uh, yeah, he basically they got false positive readings. I think it was from light reflecting off of clouds that made it look like, oh, the U.S. has just launched a barrage of nuclear warheads our direction, and you
Yeah,
had
it
like,
was one of those things where it was just like this chance alignment. Everything just had to come together perfectly to do it. But
right,
it
and you
happened.
had 4 out of 5 of them. These 4 out of 5 officers had to, or they needed a unanimous consent to recommend a retaliatory strike, and he was the only holdout. So we probably came closer to nuclear war then than we did during the Cuban Missile Strike, which also came dangerously close to a strike, uh, to triggering World War III. So, and then there's like a Wikipedia article list of close calls, or something like that. And there's other incidents that are similar to that too. Those are the two most prominent ones. But yeah, anyway, multiple occasions we've come very close. We've kind of, I think we've actually gotten lucky in avoiding it, in that the probability of us making it since 1945 without having triggered another nuclear war. Um, I think that we've been lucky that probability would have been more than 50% that we would have gotten a nuclear war, 1945 onward. Um, let's see. We can move on to the next one. There is no known method to dispose of nuclear waste safely and economically. I probably would have gotten more respondents saying that this was true if I had reached out to more uneducated leftists. But yeah, 95% of people understood that that is totally bogus. You absolutely can dispose of nuclear waste economically. It's not that difficult. There's plenty of places in the ocean where there's just sediment and piling on, and you sink a payload into that sediment, and it's unrecoverable. It's going to get covered up. It's going to subduct back into the mantle, and it's going to come out as harmless metals. Um, anyway, I guess we can move on. All nuclear reactors have the potential to produce a nuclear explosion, however unlikely. Um, I guess there is the caveat that I did say, however unlikely, and you know what is the threshold for, because technically everything is possible from a quantum physics standpoint, but in all practical purposes, this actually is false. That you can design a nuclear reactor such that there is no chance. Actually, you would be remiss. You would be. It would be very difficult to design a nuclear reactor that could produce a nuclear explosion. Um,
Yeah.
if you're not designing it specifically to be a bomb, you can't actually produce. I mean, in a certain sense, like the Chernobyl disaster was like a micronuclear explosion, in that it was a sudden, prompt critical event, but the material was not contained long enough for it to cause a nuclear bomb type thing. So
Yeah, it wasn't
yeah,
really a
you
nuclear explosion. The it just went, so hypercritical that it created hydrogen and the hydrogen exploded because of the carbon rods that were red
right,
hot. And they didn't have a containment
yeah,
building,
and
so it blew the roof off and it took all the nuclear material with it.
yeah. Yeah, and then the follow up to that: all nuclear reactors have the potential to melt down, however unlikely. So yeah, that's another one that's wrong. 50% thought that that was true, but actually, then uh, then the reaction will shut down. I guess you could call this a meltdown if the fuel plug melt, which is designed to melt at a certain temperature, melts out, and then all your
Yeah,
fuel,
that's getting overly
but
semantic, I think. Because the whole
right,
purpose of
because
the fuel
that's not
plug
a
is to melt and
meltdown,
drain it out.
right? So it's not like a normal meltdown, but
And
anyway.
that's only in
So yeah,
liquid fuel reactors anyway, which don't melt down because they're already molten.
right, exactly. Molten salt reactors. They can be designed easily to be intrinsically safe, and that there's no way to breach any containment through a runaway nuclear reaction. Uh, anyway, next one: nuclear weapons can be made to fit inside a backpack or briefcase. 55% people said that this was true. It is true. You can you can make the smallest nuclear weapon was, I think it was a few tens of kilograms, called Davy Crockett. Um, yeah, that was a little thing, but uh, it it packed like 10 tons. It was designed to target very specific targets, but you could actually make a nuclear weapon that could be carried by a single person in a large backpack that would have tens of kilotons of power. And in fact, there is, if you made enough californium, which is a very heavy isotope, that has such a tiny um, uh, critical mass that, in theory, they called it a pocket nuke. This is something that would weigh like a kilogram, and it could be fit inside somebody's pocket effectively. That's how small that they could be made and still produce huge devastation. Um, okay, next one. Nuclear bombs have peaceful applications. I thought when I wrote this question that I would have gotten 100% yes on. 100% that is true. Because there's obviously nuclear propulsion is one example of uh, nuclear power that we uh, for peaceful applications, but that
Yeah, but would you really consider
I
that a
guess
bomb?
yes. I say a bomb is a device that is functions through explosion. I would not call it a weapon. I would call it a bomb though.
I don't know. It sounds a bit like calling a rocket a bomb.
Well, it's not. I mean, it uses nuclear bombs, so it's not like a nuclear rocket where you have a nuclear reactor and you're pushing propellant through it. You're actually detonating what are effectively nuclear warheads, and those push a pusher plate, and um, so the rocket isn't what the bomb. It's the fuel is literal bombs, plural, like the big. They actually designed this. It was called Project Orion, and they consulted with Coca-Cola Company in part to figure out how to design this, because Coca-Cola designed vending machines that could rapidly, or they figured out how to get all of these cylindrical devices to be handled properly, and they're like, oh, let's use vending machine technology to figure out how we're going to sequentially detonate these bombs. Anyway, I'm going off on a tangent. The next one: no nuclear weapon has ever been used in hostility since the end of World War II. That is true. 80% of people got that correct. Next one. This one. This one, I think. is really interesting. The probability of any given American dying from a nuclear attack is higher than any other disaster scenario. Only 2 out of the 20 respondents, 10%, said that that was true. Now, that's not a fact that you could look up, but I think any reasonable assessment of the probabilities suggests that is definitely true, and I could back that up.
I don't know. That sounds
So,
iffy to me when you think about so many of the other disasters we've seen,
okay,
even just in the
so let's
U.S.,
dive
and
into
then
that.
what they've told us about the potential for it.
Yeah. Well, let's dive into that. So, if a full-scale nuclear war were to occur, I think you would agree that 100 million people dying is a reasonable um, scale of that.
In the
Yes.
U.S.,
Yeah.
I don't know. That's like a
Full-scale
third of the
nuclear attack.
population.
Yeah.
I mean,
Well,
you'd
like
have
more
to
than a
drop a
third of the
lot of nukes to
population
do
lives in cities.
that.
Well, Russia has like 4,000 nuclear weapons and tons of rockets to do it. So that's what it's been estimated at. Um, Maybe 1 to 200 million Americans, the majority. And if you look at fallout maps, you know, I mean, we go back up to the top. Most people are not prepared for a nuclear war. So I think it's pretty reasonable to expect 100 million people to die if it were a full-scale nuclear bombardment by Russia, maybe even China. Maybe not quite as many people would probably die from China attacking us, but it would still be in the tens of millions. And yeah, it would be absolutely devastating. So
Tens of
that's
millions, I think
the
I could see, but most of the devastation would be economic. But
okay.
you could do pretty
Well,
much the
and
same kind of economic devastation if you just had like really bad timing of hurricanes on the east coast and an earthquake on the west coast to the point where you took down the national power grid.
and that would probably be part of the attack. But okay, let's. What
But
would
I'm
you
talking about
say?
just from a natural disaster that could happen.
Um, well, I don't know
I
about.
mean, it'd have to be very badly timed, but it's not impossible, and
Yeah.
that's not something you can prevent with diplomacy or anything.
So what scenario are you picturing, and how many people do you expect to die? Like worst case scenario from a natural disaster. What are you picturing?
It basically, I mean, it would be easy hitting the coasts, taking out millions of people. But I'm also thinking of like what we saw
Millions
with
of
the cascading failures in Helene. We saw that before in Texas. We saw that even before that with the Northeast. And if that happened
well,
kind
I
of on
mean,
both coasts at the same time, that could easily, I think, take down the national power grid, which means we'd be without power for at least a couple of years, I think,
I
considering how
don't think
long
we
it
would be
takes to get
without
everything
power
back
for.
up and running. And it's
Yeah,
the
I
same
don't think
problem.
that we
People
would.
don't have that much in emergency supplies.
Well, I don't think that people would be without power for years because the infrastructure, the that is that would mostly be there, and you would still have a lot of places that have the like places like sure the East Coast gets destroyed and the West Coast gets destroyed, and then there's all the places in the middle, like where I live, that still have working infrastructure and can bring in the people from these disaster scenarios. So, but I want to discuss, the probabilities and the expected value of how many people per year could we estimate could be expected to die in the long term from nuclear war. Well, if it kills 100 million people, um, in a kind of a worst case scenario, what is the probability that we will see that scenario in any given year? And I would estimate that at between 0.1% and 1%, based on the fact that we've come very close to nuclear war many times in the past. And, I mean, in a certain sense, we have been involved in one nuclear war. I would be surprised if Earth went 1,000 years without somebody going crazy and all these nukes get hurled at each other. Do you think that that is a reasonable assessment?
I don't know. I don't think the probabilities really work that way, because even with a couple of things that we've talked about, that was back when the USSR was a thing. And yeah, I know Russia's powerful and they still have a lot of nukes, but they are not the USSR. And especially when you
Well, yeah,
consider the fact
they're
that
no longer the USSR, but
it wouldn't be Russia versus America if they want to launch those nukes. They basically have to launch it at all of our allies too. And so that would spread it out even thinner. And even then, because it is so much easier for us to take down the Russian civilization, where you really only have to take down two cities, Moscow and St. Petersburg. And then you've basically destroyed Russia as a country. Yeah, you still have a lot of people there, but as far as a country you have to worry about as a superpower, they'd be gone. We have many more cities. We're much more spread out. We've got allies with a ton of cities that are also kind of spread out. I don't see a real plausible. Everyone talks about the idea of, one nutcase, getting into power and launching the nukes.
Well, one nutcase could destroy a city. One nutcase could destroy a city, but really the
yeah, but that wouldn't trigger like whole scale global thermonuclear war.
Well, no, you're right there, but I'm also like, it almost sounds like you're discounting, scenarios where tensions have escalated over the course of years. Maybe right now tensions aren't so bad, but things can escalate over the courses of years, or even in some cases days to weeks, to the point where we might be standing on the precipice of a nuclear holocaust. A few weeks from now, and I think it's overly optimistic to say that the odds that something like that would happen, say in 2026, are less than 1 in 1,000. So that's my justification there. So I would estimate that on average, a nuclear war in the long term would claim 100,000 to 1,000,000 lives per year. And no other disaster scenario comes even close to that. But this is a subjective assessment.
I'm trying to think of the name of the volcano. But it was something like,
are you talking about Tambora?
When it blew with a force greater than all of the nuclear bombs that have ever existed, or something like that.
There was Krakatoa was the largest natural explosion ever.
That might be.
You might be thinking of that, and there was also Tambora, which did cause they said the year without a summer, which is a bit of an exaggeration, but that could.
And then, of course, the thing is, it's not called the KT event anymore. I forget what they changed it to, but you would have to something like take the world's nuclear arsenal and multiply it by 100 million or something like that to get the force of that asteroid strike.
Yeah,
And I mean, a
an
much
asteroid
smaller
strike like
asteroid
that
strike, keeping
happens.
in mind that when an asteroid strikes, it's probably going to break into pieces. If you had that was, very badly placed over in North America, and it broke up and hit a bunch of cities, that'd be just like a nuclear war, I would think.
Yes, although to get to that scale, an asteroid of that scale hits the Earth maybe once every 100 million years. So you're talking about on the order of one person dying per year. That's the problem. Is like the frequency of nuclear war. Yeah, it's hard. It's very hard to estimate, but it all depends on the stability of global politics, which historically is
Well, it's
not
also highly
all that
speculative because there's
stable.
never been one. There have been asteroid strikes,
Right,
we can study those, but there's never been, an actual nuclear exchange before.
right, but that raises the issue of like not knowing what the probability is not usually a good for an argument of reassurance. If you don't know how likely or unlikely something is, that's evidence that it very well could be a likely thing.
But I think it's also the case where, an asteroid strike, a hurricane, volcanic eruption, those things are kind of random. Whereas you yourself said a nuclear strike is only going to happen, after escalating tensions and, after diplomacy has failed. That means there's probably 100 different ways to prevent it. There would have to be massive
Well,
failures on both sides of the equation for it to lead to a full-on nuclear exchange.
well, yes, but this is failures in politics. Are those uncommon or common?
On that
um,
scale, they're actually pretty uncommon.
yeah, I mean, obviously it hasn't happened yet, but it's come damn close
But
to
I
it.
mean, even if you think, even if you think about like the worst wars that have been fought, and I'm not thinking of like the overall war, because you have a war that goes on for 100 years are going to kill a lot of people. But I'm just thinking of like individual battles. You've got, even discounting the Hiroshima and Nagasaki. You've got Dresden. You've got the Battle of Stalingrad. You've got some attacks that someone would consider basically the equivalent of nuking that city minus the radiation. But that is not the way typically things happen in war.
How do you mean?
I mean, normally with war, what we see are, you know, mostly ground troops with some air and things like that, trying to, claim and take and keep, different parts of land, like what's going on in Ukraine right now. Russia moved in to take over the disputed areas and now they're holding the ground. It's normally not a case of, I want to absolutely destroy entire cities and the infrastructure and everything that, I could move in and use once I take over.
Well, yeah, I mean that usually is the case, and actually some of these subsequent questions in this speak to that. The question is like when all of that fails, and what is the probability that it will fail that badly, and we will end up with a total nuclear holocaust. And hey, let's take my estimate, one in 10, or your let's take a more cautious estimate and say the odds of a nuclear war breaking out in any given year, um, more than 6 months out, is 1 in 10,000, and that the nuclear war would kill only 20 million people. Well, that's still that's still killing 2,000 people per year, which there's very few events that come close to that. I guess you could say that COVID and the like, those viral outbreaks are do kill on average more than 2,000 people a
Yeah,
year.
well, no,
So
traffic accidents kill an order of magnitude more than that.
those, yes, but I wouldn't consider those to be disasters. Those are just that's the constant background noise of you know,
Um,
that's
I think
not
we've given
one
enough
big
people to mentally chew on.
anyway.
We should probably get through the rest of these questions, though.
Yeah, you're right. Anyway, so the next one, no two nuclear powers have engaged in a major 10,000 casualty direct military conflict since their procurement. That is true. Only half of respondents got that. I think the biggest conflict was between a small war between India and Pakistan that killed several hundred on each side. A full-scale nuclear exchange between the U.S. and Russia would result in the deaths of 99% of the population. Most people got that right. It wouldn't kill 99%. It would probably kill more than 10%, though. Let's see, a single nuclear weapon could kill more than 1 million people. I'm surprised only 80% of people got this one correct. Obviously, it could if you detonated in the middle of a large city. Little Boy was never
Actually,
tested
in the
before
air
use.
above a large city would be more, because you get a better blast radius than you would detonating it on the ground.
Well, it depends. It depends primarily on the wind. If you detonate it on the ground, the devastation is more localized, but it produces a lot more fallout to the point where you can kill a lot more people through a ground burst with the fallout.
I
In
think
fact,
that's
you probably
debatable.
would not. I mean, you're, if you look up some of these maps, like Fallout map, um, if
And the
you're talking
fallout
about
is
a
not
mega
what's
10,
doing most of the damage anyway. It's the shock wave that's doing most of the damage. And the
no,
shock
with a
wave is going
ground
to hit a
burst,
greater
the
area
number
if
of
you
people
detonate
who,
it in the air.
yeah, the shock wave in the air would kill people. But we're talking about if you detonated uh, a 1 megaton nuclear warhead on the ground. See, it's not just the fission products that produces. It causes neutron activation of all of the ground that in the immediate vicinity of that bomb, and disperses that over hundreds of square miles. And by hundreds of square miles, I mean the region in which, if you stood outside, you would be exposed to lethal doses of radiation is hundreds of square miles. So if there was like a large nuclear bomb that was detonated just west of a major U.S. city, most of the people in that city would be exposed to lethal doses of radiation. So it would actually potentially be more devastating. And if you detonated it at the right time, where like prevailing winds are traveling from like Philadelphia through New York, there's like um, a large amount of population along that strip, and it could kill tens of millions.
I mean,
Yeah,
I
I've
could see
looked
that.
at these. Yeah. So uh, let's see. The next question was, Little Boy was never tested before use. I thought that this was just an interesting factoid. Yeah, Little Boy
Yeah.
was not tested. The Trinity test was a test of Fat Man, or a Fat Man, the same model, uh, um, because of the aforementioned, plutonium implosion. Little Boy, the bomb was U-235. They didn't want to waste any U-235, which is incredibly difficult to procure. Um, on doing a test.
Well, and
And
also
it's
they were a
interesting
lot
because,
more sure it was just going to work.
yeah, they were
There were a lot
totally
fewer
confident
question
it was going to
marks with
work.
that.
Yeah, it's interesting because how often in science do you think, oh, I have this idea that works in theory, No, I'm 100% positive this is going to work. We're going to create an explosion larger than anything that the world has ever seen if we just do this one thing. We don't even have to test it. Let's just do it. It's kind of an absurd thing, but that's really how it went down.
Yeah.
Um, the next question, it is possible to produce a nuclear weapon so powerful it could exterminate humanity. Um, only 35% of people said that this was true. It is true. I believe it was Teller who came up with a doomsday device, absolutely massive thermonuclear bomb that if that went off, it would produce so much fallout that humanity would be done. You could kill everybody on the planet. So
I mean, how much
that
are we
is true.
talking about though, and how realistic is it?
Oh, it would be far more than, it would be orders of magnitude more than the entire nuclear arsenal of
Yeah.
Russia and the U.S. combined. Because you could make this thing like you could make
Well,
a
you can
bomb,
always say,
and
if
it's
you make it big enough, you can blow the planet apart.
exactly.
But at
But
some
there
point, you
has
have to
been
think about
proposals.
practicality.
This was a proposal. This was a fully engineered proposal by Teller that we could make a device that would wipe out humanity as a way to threaten the world into peace. Was his motive there? Like,
Oh yeah,
you
I
know,
think I know the one
you,
you're talking
yeah.
about. Yeah, and there are a lot of people that are
So,
very skeptical that A, it could have been done, and B, it would have actually killed off all of humanity.
hmm. Well, I'll have to look more into that skepticism. My understanding is that yeah, you can make nuclear weapons arbitrarily large and produce so much fallout that basically everyone would have to stay underground for hundreds of years. And I think the odds that humanity is going to survive an environment where they can't go outside for 400 years is pretty low. Um, The next one, above ground nuclear testing during the 20th century has likely resulted in over 100,000 deaths worldwide due to cancer. This is by far the most controversial question I included. I included it because, like, uh, it was more of like an opinion thing. Um, I pegged that at about 50% chance of being true. And it all comes down to the old crux of the argument, the linear no threshold.
Oh
And
yeah,
where exactly is
yeah.
that threshold? Um, because it is possible that not only did it not kill that many people, it could be that the trace amounts of increased radiation, stimulated DNA repair mechanisms to the point where it was actually beneficial. I don't believe that is the case, but um, I'd
Yeah,
say there's like a fifty
it's just
percent
things like
chance.
that are. I mean, if you've got like Chernobyl, where it just hits a whole bunch of people concentrated into one area, then yeah, you can estimate that that resulted in whatever it is, 200 cancer deaths or 2,000 or whatever it is, that this many cancer deaths. But when you're talking about all of these remote detonations that were far away from
Hmm.
populated areas, and you're talking about what is what is the fallout going to do after it gets dispersed into the atmosphere? The answer, I would
Yeah.
think the answer is probably not a lot.
Well, the most credible study on this estimated that around 11,000 Americans, because there was an increase in thyroid cancer that corresponded to the increase in iodine, radioactive iodine in the environment.
Yeah.
And this kind of makes sense because that bioaccumulates in the thyroid. And they attributed 11,000 American deaths due to thyroid cancer due to nuclear testing. Um, so Now, Americans got the worst of that exposure because we had a lot. Our entire food supply is just west. Is about 1,000 miles west of where they tested all of these nuclear weapons um, in Nevada, just north of Las Vegas, basically. So,
But if you're talking
how
about
that
thyroid
extrapolates
cancer,
to the
that's
rest.
because of radioactive iodine, which is going to be gone in a couple of months.
There are some isotopes. I think one of the isotopes lasts about 8 years. Mm, Iodine 131, I believe it is. Oh, no, wait, that's 8 days. There are some other ones, though. Let's see.
Because usually that's what you're worried about right after if there's a nuclear event at a reactor, the first thing they do is go around and give everyone KI pills and have them shelter in
Okay. Yeah,
place.
there.
But even that's going to depend
Iodine.
on like which way the wind's blowing, literally.
Yeah. Actually, the main one of concern is iodine 131, which has a half-life of 8 days. So most of that is just going to stay within the U.S. Um, but Yeah, and there's strontium 90 is another one of concern because that bioaccumulates in people's bones and can cause leukemia. Um, so yeah, it's really hard to extrapolate these numbers because the 11,000, that's just in the U.S. and that was just thyroid cancer. What is it long term for like strontium 90 exposure for the entire world? That all comes down to where that threshold is, and it's very difficult to say whether it's you know killed killed 1 or 200,000 people or killed effectively nobody.
Yeah.
um, anyway, um, but it is a concern, and it is a legitimate concern that since we don't know what the threshold is, the nuclear test banning was a very prudent decision in my opinion. Okay, is it possible to produce a nuclear weapon so powerful? No, wait, that was the one we covered. The final question was, all nuclear weapons produced by the US are accounted for. 20% of people got this wrong because, yeah, they are not accounted for.
Yeah.
There were a couple of like plane crashes where the nuclear bombs just sunk to the bottom of the ocean where conceivably somebody could recover them. There's a lot of missing nuclear weapons from the USSR. You know,
Yeah.
who knew that when a country collapses, they can't keep track of all of their assets? So yeah, that's terrifying. Fortunately, no terrorist has gotten a hold of them, insofar as we know. Anyways,
All
so
right.
that's the whole thing of the quiz. I thought it'd be interesting.
Yeah. That sounds good. It'd be kind of cool if you could do it at a larger scale so we could really see.
Yeah, yeah. I was thinking I might try making more of these quizzes. On various subjects. Use the feedback from this to make the quizzes better and see what other misconceptions are. I thought that, yeah, it's kind of opened my eyes to what some people don't realize. Like, I thought everybody knew that a nuclear bomb could be made to fit in a backpack or briefcase, but most people didn't.
Mm. All right. Well, since we've only got like 25 minutes left, let me go through the chats. Of course, we got Fighting Zen over here on Rumble. How's my vacation? It was great. He's got his usual links. Let's see. So fed up about people blubbering about the death of melody in music. There's such thing as melodic techno, melodic trance, melodic house, and plenty of Bandcamp and BandLab musicians. Who would have gotten Dolly Parton's attention or even Prince's respect if he was still with us? The fact that AI is bringing long dead genres back and giving people who have interesting ideas without the skills a hand up. Yeah, that's always a good thing. Immigration isn't the problem. It's the mixed economy and a big government. It's always big government. Oh, and moronic politicians banning chemtrails without knowing anything about how chemicals work. Hitchens is right. Religion poisons everything. I'll mostly scroll through these. I looked at Acuna as a search engine, and I don't remember specifics about it, but I remember not being that impressed for some reason. I can't give you details, though. So much for Trump not starting any wars. I knew he was as funny as Obama and Edwin Edwards. Yeah.
Well, I mean, could you say that he started a war here? I mean, this wasn't exactly a war.
Well, that's what a lot
I mean,
of the Trump
he
people
just,
are saying. No, it was just a strategic bombing or whatever.
well, it does look like that is the case. He knocked out Fordeaux and didn't kill anybody that, or at least maybe, a few people died. I don't know, but this didn't blow up into a larger conflict. This is not Afghanistan.
Yeah.
This is not Iraq. At least so far, it does remain to be seen whether or not the ceasefire has proved successful. Yeah.
Yeah, so let's see. Where was I on the YouTube comments? There's an elderly Iranian thinking, maybe the Shah wasn't so bad. Probably.
Yeah.
The reason California can't grift, the reason California is against nuclear power is because they can't grift on it.
I don't trust the Iranian regime. One Ayatollah.
Why is YouTube's comments so wonky now? So many comments disappear without rhyme or reason. That's been the case for a while.
Oh yeah, and that's something that this is what got me to abandon the YouTube platform. And I use GrayJ. Have you heard of GrayJ?
Oh yeah, I know GrayJ.
Yeah, GrayJ is fantastic. I love Louis Rossman. Love that he did that for us. Because the comments on YouTube, you post something, and if it is the slightest bit controversial, it'll make it look like you've posted it, like on the app or whatever. Oh, I see my comment there. But if you refresh, if you go back and navigate to it after a few seconds, it'll be gone. And it's I tested this in a lot of cases. Sometimes I would, if I criticized Joe Biden, I would be much more likely to have that comment deleted than if I literally posted the exact same comment but switched Biden to Trump. That was probably the final straw. I was like, I am not going to engage with this platform directly anymore.
Yeah. Thoughts on any recent Supreme Court cases? Not that have gelled enough in my head to speak about off the cuff. I've been keeping up with them, of course, and I might cover them in videos, or I might just do a story on them in the podcast.
There was that obvious Supreme Court case where they said, yes, states can ban so-called gender-affirming care for minors. Yeah. Yeah, I mean,
and there was the one said, no, you're just a district judge. You cannot block things for the entire country.
Right, that was good. Yeah, with that gender affirming care, I mean, it seems so obvious. If a state gets to set the age of consent for sexual intercourse, you'd think that they would also be able to set the age of consent for permanent life-altering surgeries and hormone treatments.
Oh yeah. What are the odds voluntarism and anarcho-capitalism or something like that finally wins out someday? That would be an interesting question. What do you think? How do you think those odds compare to the odds of a nuclear war?
I think I think some of that has to do with the subset of your population and their personality trends, in that, like, earlier on in the US, uh, the US population consisted of people who were so sick of their government butting into their business and were smart enough to make it on their own, that we generally had a libertarian society. But then as we ran out of room and just started, you know, that trend kind of died out, and so then you no longer had a majority of population who were rugged individualists, which I think is necessary for basically any successful libertarian place, which I want to see. But yeah,
Yeah, SKM, look up Gray J. Gray J, kind of the idea is it's going back to the idea of protocols, not platforms. And so the idea is, like, instead of trying to follow me on YouTube or on Odyssey or on Rumble or on all these different places, I just have one identity, and then I can post to any of these places, but you can just get it like when I post a video. You can say, okay, just give me whenever Shane posts a video. But you can also say, like, I'd rather watch it on Rumble if it's there, otherwise YouTube or whatever. So it's more about following the identity of the person, of the creator you want to follow, than trying to be tied to a platform and being worried about them not showing you the videos even though you're subscribed to them and things like that.
yep, it kind of eliminates their power to censor and curate the content. I mean, they could take it off their platform, you know, but yeah, and it takes away their ability to manipulate, um, what information, like, as long as they are hosting the information, as long as they're hosting the video, should be able to access it and then decide what other platform you want to, select videos for recommendations. But yeah, it shouldn't just be up to the person who has the video on their servers.
Well, and there's the thing, even if you say, hey, I want to follow Shane Killian, but I want to watch YouTube, but then YouTube takes the video down for whatever reason, it'll show you,
Right.
One of the other places I have it, Odyssey or Rumble or wherever.
Hmm.
Yeah, Fighting Zen said Google is run by
Yeah.
partisan hacks. True, true, true. I'm not sure what Dapperton was talking about when he says reminds me of Watchmen, the movie, but I think it was probably one of the nuclear things that we were talking about. I notice how YouTube has changed over the years. It used to be indie channels and content. Now it's all corporate, and cronies get priority and exposure. Yeah, it's just so frustrating because, like, I made that video where I went through Judge Alsop's ruling in Bart's v. Anthropic, which is something a lot of people were talking about. If you search that on YouTube, you don't see my video. I'm not saying you see it way down. You don't see it at all. And you see all of
Yeah.
these videos of all of these hacks going, I go, yeah, down with AI, and just misleading you about what the judge said, even ones who have, fewer views than I do. And I
Yeah,
was looking
I
at the
hate how
analytics,
when
and the only search that was driving people to that video was the search for my name.
yeah, and
There have to
I
be
hate
people who
how
are searching for, like, AI ruling or AI judge ruling or the actual case or whatever.
yeah.
There have to have been people searching for that. Not a single one of them were shown my video.
Yeah, I hate when there's some sort of popular or controversial video that has come out, and I'll go and I'll try to search for that video, and I'll even include terms like raw, or whatever. And all I get is all of these news stories that have selectively edited the video, and I can't look at the raw thing, and I can't find any, analysis, or I can't get, the raw footage that I'm looking for because it's all MSNBC, CNN. It's like, why? What is the point of even giving those companies a platform on YouTube? I mean, it's called YouTube. They have
when they
their
already have
own
their own
websites. They
platform.
have their already have their own platforms. They already have broadcasts. They have their own websites. Nobody's going to have any trouble going to CNN's website themselves if they want to watch CNN. And you put that on YouTube, and all of the indie content creators are just.
Going back to
But
volcanoes,
yeah,
have you ever
that's.
heard about the volcanic winter of 536 AD? People always say the fall of Rome in 450 is the beginning of the Middle Ages, but some say it's this.
I haven't heard about that one specifically. Oh, there is a natural disaster event that when I was researching this, uh, that is a major contender for one of the most dangerous natural disaster events. It does hinge on loss of the power grid. I'm sure you're familiar with the Carrington event, right?
Now, which one was that?
That was the solar flare or solar storm in the 1800s that like knocked out telegraph stations and it caused
Oh,
problems
yeah.
with telegraphs. But
Yeah.
and if that happened today, it might cause weeks of disruption to our power grid. However, what's really interesting is that there is this researcher named Miyake who noticed that carbon-14 concentrations across around the world spiked in specific years, like they went up 10% or something, and they realized this must have been some particularly powerful solar storm. Now, obviously, nobody noticed noticed any of these events when they happened, because all it did was increase carbon-14, and it would have knocked out electronics if there were any electronics in the last time this happened, which was like 1,000 years ago. But basically, every 2,500 years or so on average, you get this major solar storm that's like 10 or 100 times as powerful as a Carrington event thing. And if one of those happens, it would probably destroy all of the power lines. It would fry everything. We would have complete disruption for months or maybe years. And it would be the same thing as a targeted EMP attack over the US. It could cause widespread disruption of food supplies, mass starvation, and it would affect the entire world, not just the US.
Yeah, there's a lot of things like that. Like if there was like the wrong kind of supernova that was like aligned directly with us, all the radiation it would throw our way would fry an entire hemisphere, basically kill half the world, literally. And not only is there nothing we could do about it, we wouldn't even know that it was coming because it travels at the speed of light.
Right? Yeah. Yeah, I think I ran the numbers on supernovas, and so they figured that the Miyake event occurred too frequently to be attributed to a supernova. So supernovas are like those might be like million-year events when something that powerful happens close enough or directed at us precisely enough. Um, so that's interesting, but yeah, that is a possibility too. But yeah, this Miyake event, which is probably solar, um, it's rather ominous, fascinating
Oh, I mean,
to
you just get a
research.
good, coronal mass ejection and you could do a lot of damage.
Right. And that's probably what it is. It's a coronal mass ejection, but it's like there's evidence in the tree rings that something 10 or 100 times bigger than the Carrington event, which was a large coronal mass ejection that hit Earth, um, and that so that happens randomly every 2,500 years or so on average. Pretty ominous, pretty crazy.
Yeah. There are so many things that could wipe us out.
Mm. You know, the real trick is actually getting, wiping everybody out. Like you can get events that wipe out 99% of the population, but then you get those preppers who, have already prepared to hole up in their basement for months or years, and then they'll just reemerge, once everyone else is wiped out, and hey, look at all this free stuff.
Or even
um,
just people who just fortuitously happen to be in, just the right place to avoid everything.
yeah. Um, it made me wonder, like, what would it take to kill absolutely everyone? And I think it would require. I worked this out as a possible scenario. Um, if you could create an explosion large enough that it increased the concentration of carbon-14 in the atmosphere to lethal levels, um, then yeah, that's pretty much going to kill everybody, because you can't even just filter the air to bring it down to you to breathe, and
Yeah,
it'll
but
last
what
for
is a lethal
thousands of
level of
years.
carbon-14?
Um, let's see. I know I did the math at some point, but I think it's going to be on the order of 1 million times the normal concentrations. Um,
That sounds a bit low, actually. I'd be surprised if it went a lot higher.
uh, don't quote me on that. I could be off by 3 orders of magnitude. Uh, but it there is an amount of carbon-14 that would be, and by lethal I mean, like, if you're outside, if you're ingesting carbon-14, it's in your body. Um, is it going to kill you over the course of years?
Yeah.
That's the question.
Because the carbon-14 would
Is it
go
going to
into the
expose
food.
you?
It would get in the food chain
If
and
it's
you'd
going
all
to
eat it.
Yeah, exactly. And if it's going to expose you to about 5 sieverts per year, that's probably going to kill you, because you can recover. People have recovered from more than that radiation exposure over the course of a year, but it did cause huge health problems for those people. So, um, yeah, more than 1 sievert per year, less than 10 sieverts per year, and that's going to be lethal. Um, anyway, I did think of one really out there scenario that could happen. And it kind of depends on the existence of Planet Nine and exactly how big it is. Because if you have Planet Nine, it's possible that it's small enough that it has an ocean of liquid hydrogen. And if it has an ocean of liquid hydrogen, um, cryogenic liquid hydrogen, not like, the super high pressure, high temperature hydrogen that exists in the Jovian planets, but, like really cold liquid hydrogen, conceivably, if some whack job put a large enough nuclear weapon and descended that, entered into the atmosphere, into the ocean, detonated it far below the surface of the ocean, perhaps that would trigger a thermonuclear detonation of all of the hydrogen on that planet. And then the entire planet goes up in one big thermonuclear detonation, and that I calculated would increase carbon-14 levels in the atmosphere beyond lethal doses and would exterminate all of humanity.
Sounds almost like the plot for When Worlds Collide.
I'm not familiar with that.
Yeah, except the other planet ended up being a paradise. But
Oh, was
yeah,
that
yeah,
was that
planet comes by close to
2010?
Earth and destroys Earth. Yeah.
Oh yeah, that was Melancholia.
The what?
Now, in the movie Melancholia, there was a rogue planet that collided with Earth.
Oh, I don't see that. This one wasn't a collision. It was just a nearby pass. But yeah, the tidal forces
And
and
then,
everything destroyed the Earth.
uh,
We got 2 minutes left. So this is time for everyone to get in their last thoughts. I think I've talked about voter ID quite a bit. So just check the archives. And I think I might have been a couple minutes late getting things started. So maybe more like 4 minutes. So you got anything else you want to talk about, Fourth?
no, I think we've covered things pretty exhaustively.
Yeah, I've just been, maybe it's just growing up on the tail end of the Cold War, but it's just always having the feeling that the effects of a nuclear exchange would not be the humanity ending, event that everyone keeps saying it is.
Well, it wouldn't be humanity ending, but I think it would be
I think
pretty
my
bad.
cam
It would.
froze. Yeah, my camera's frozen. Wait.
I do believe that it would be, nearly approximately half of the entire country would die in a full-scale nuclear attack. Um, possibly double-digit percentage if it's from China. Definitely, well into double-digit percentage if it's from Russia. Um, and then, yeah, you just like it's hard to justify saying that the probability of that occurring is vanishingly low. Yeah, maybe you could justify getting down to like 0.1%, like I said, maybe even
Am I still broadcasting?
0.01%.
Did this thing crash on me?
Oh, I don't know. Let's see.
Yeah, you're hearing me over Discord. I don't know if I'm going out to YouTube anymore. This
Well,
might
let
have
me.
dropped.
I'll just hop on YouTube and see. Um,
It's not looking good from my end. I'm getting an alert that says viewers will experience buffering.
oh, hold on. I got a video from you that says it's live.
Okay.
Let's see.
Well, with 1 minute to go, I guess.
Yeah, we're still live.
Okay.
Okay.
Okay. I was worried that because my cam froze. And then I didn't see anything else updating, so I didn't know if we were.
Oh, one last question. All right, what is your opinion on voter ID? I think there are ways of doing that that don't necessarily require ID, but I
Well,
am
I mean,
all
you
for
could do it
verifying.
with
Yeah,
just sensible voter registration. And my big problem with it is you're
yeah.
basically forcing everyone into their wonderful, horribly non-private and horribly insecure real ID. That's my big problem.
Yeah. I mean that. I am all for creating a voter system that lots of different ways to implementing it. That, um, but yeah, so
How
maybe
about just, I
maybe
mean,
if it's
like you
implemented
register to
properly.
vote, they take your picture, you show up and you say, hi, I'm Shane Killian, I want to vote. When they pull up your information, it pulls up your picture too. They can see if it's you. If anything, that would be better
Exactly.
than an ID card because it's a lot less likely that you could, hack it or whatever than go and buy a fake ID.
Exactly. I'd be all for that.
There's just better ways of doing it.
Hmm.
All right, I think that's it. We are past the 2 hour mark. Thanks, Fourth Root. This was very interesting.
Well, thank you. I thought it was interesting too. I really appreciated being able to talk to you about these issues.
Yeah, even the stuff we didn't agree on, I hope we gave people enough to think about and chew over and decide for themselves. So,
Yeah, I really hope that people found it interesting. I know that I have a tendency to nerd out, especially about nuclear physics and go over people's heads, but I think your audience is kind of people who might just get a kick out of that.
maybe I've covered enough nuclear stuff for it. And that's because I have, family members who work at nuclear power plants and things like that. So
Yeah, my
I love
dad
picking their
worked at
brains.
Rancho Seco my father worked at Rancho Seco nuclear power plants up until it closed. So um, that's basically where my enthusiasm comes from.
Cool. Well, thanks for joining me. Thanks for everyone who chatted. Dapperton, Zen, SKM, Fun with Facts, Checkmate, all of y'all. And thanks to everyone who was watching. Until next time, stay strong.